Hello sir, my name is Abhijit Kumar Singh. I am of class 12A. My roll number is 8. I am here with my physics project and the topic of the project is behavior of a dipole in uniform and non-uniform electric field. First, behavior of dipole in uniform electric field. A pair of electric charges with an equal magnitude but opposite charges separated by a distance d is known as an electric dipole. The electric dipole moment for this is defined as the product of the magnitude of these charges and the distance between them. The electric dipole moment is a vector having defined direction from the negative charge to the positive charge. The net force acting on a dipole placed in a uniform electric field is zero. The force on the two charges constituting the dipole are equal and opposite, hence the net force is zero. If the dipole is kept in an external electric field, it experiences a rotating effect. By external electric field, we mean that electric field that is not induced by dipole itself. The rotating effect is also called torque on the dipole. A. When dipole length is increased. When dipole length is increased, net force acting on a dipole is zero, as net force is independent of dipole length. Torque acting on the dipole when dipole length increases. T equal to P sin theta. T equal to Q 2A sin theta. So T is directly proportional to length. Hence, as dipole length increases, torque also increases. B. When dipole is turned by theta from its equilibrium position, the torque tends to orient the dipole parallel to the electric field. The work is stored at the potential energy of the system. We can then write U equal to Pe cos pi by 2 minus cos theta, that is equal to minus Pe cos theta, that is equal to negative of potential energy. When theta equal to 0, that is P is aligned in the direction of E, potential energy is minimum in this case. When theta equal to pi, that is P is aligned in the opposite direction of E, hence potential energy is maximum in this case. C. When two parallel dipoles are placed in uniform electric field. Since dipoles are placed in uniform electric field, so it experiences zero electric force. Also, dipoles are placed to parallel to electric fields. Hence, the angle between P and E is zero. That is theta equal to zero. So, torque T equal to P sin theta will be equal to zero. Here, work done will also be equal to zero in this case. D. When two perpendicular dipoles are placed in uniform electric field, the net force is zero but the torque is maximum. Hence, dipoles will rotate to align itself along the field. Now, second topic, behavior of dipole in non-uniform electric field. When electric dipole is placed in non-uniform electric field, the net force will be non-zero. There will also be torque acting on the system. When dipole moment P is parallel or antiparallel to the external electric field, the net force is zero, but there is a force on the dipole E, which is not uniform. It is seen that when P is parallel to A, dipole has the net force in the direction of increasing field, and when P is anti-parallel to E, the net force on the dipole is in the direction of decreasing field. Force depends on the orientation of dipole movement with respect to the external field. Hence, an electric dipole placed in non-uniform electric field experiences both a torque and a net force. A. When magnitude of electric field increases, let us assume that the field is increasing towards positive x-axis. As electric field is moved towards positive x-axis, force acting on plus q greater than force acting on minus q. So total force F net q equal to E1x minus E2x. Here E1 is greater than E2 are different. Hence dipole will move along the positive x-axis. Torque is given as P cross E. When magnitude of electric field decreases, let us assume that field is decreasing towards positive x-axis. As electric field is less towards positive side of x-axis, force acting on plus q lesser than the force acting on minus q. So total force F net equal to q E1x minus E2x. Here E1 is smaller than E2 are different. Hence, the dipole will move along the negative x-axis. Torque is given as P into A. Motion taken by dipole in uniform electric field. When dipole moment P is parallel or anti-parallel to external field E, the net torque is zero, but there is a force on dipole E which is not uniform. It is seen that when P is parallel to E, dipole have a net force in the direction of increasing field. And when P is anti-parallel to E, the net force on dipole is in the direction of decreasing field. Force depends on the orientation of dipole moment with respect to